Hello student and welcome to 8th standard. Let's start with our first chapter, rational numbers. Let's see the introduction. In mathematics, we frequently come across simple equations to be solved. For example, the equation x plus 2 is equal to 13. What will be the value of x? Let's solve this. Now, I will keep x here and I will take the plus 2 on the other side, which becomes minus 2. So, the value of x is equal to 11. So, when this is solved, we get x is equal to 11 because this value of x satisfies the given equation. The solution 11 is a natural number. Do you know the natural numbers? Yes, the numbers which start from 1, 2, 3, 4 and so on are called natural numbers. The first natural number is 1. On the other hand, for the equation x plus 5 is equal to 5. The solution gives the whole number 0. Now let's solve this equation. X plus 5 is equal to 5. I will keep x on this side and take this plus 6, which becomes minus on the other side. So the value of x is equal to 0. So when we add 0 to 5, we get the same answer. If we consider only natural numbers, equation 2, which means this equation cannot be solved because natural numbers start from 1 and 0 is not a natural number, it is a whole number. To solve equations like 2, we added the number 0 to the collection of natural numbers and obtained the whole numbers. Even whole numbers will not be sufficient to solve equation of type 3. Let's solve this equation. Now I have this equation x plus 18 is equal to 5. Let's find out the value of x. I will keep x here and I will shift this plus 18 on the other hand. But now if you notice, the first one is the small number, the next one is the big number. When the one number is positive and the other number is negative, we do the subtraction, which means 18 minus 5. The answer is 13 and the sign of the bigger number. So 18 is the bigger number, so I will give the sign as minus. Now notice this answer. We got the value of x is equal to minus 13, which is not a natural number and whole number. Do you see why we require the number minus 13, which is not a whole number? This leads us to think of integers. Integers means the positive and the negative numbers together. Note that the positive integers correspond to natural numbers. One may think that we have enough numbers to solve all simple equations with the available list of integers. Consider the equation 2x is equal to 3 and 5x plus 7 is equal to 0, for which we cannot find a solution from the integers. Let's solve them. Now, I will keep x on this side. 2 is multiplied here. There is no sign between 2 and x. So it means it has the sign of multiplication. Now I will take this 2 on the other side. So it is divisible on the other side. So value of x is 3 by 2, which is again not a whole number, not a natural number and not an integer. Let's solve this also. Now I will keep 5x on this side. 0 minus 7. So I got minus 7 as the answer. Now I will keep x on this side and take the 5 on the other side. Again, if you see, it is not a whole number or a natural number or an integer. We need the numbers 3 by 2 to solve equation 4 and minus 7 upon 5 to solve equation 5. This leads us to the collection of rational numbers. Now students, did you know why we have discovered rational numbers? We have already seen basic operations on rational numbers. We now try to explore some properties of operations on the different types of numbers seen so far. Okay, let's see properties of rational numbers. First one is the closure property. Let's see the closure property for whole numbers. Let us revisit the closure property for all the operations on the whole numbers in brief. Now see, the first operation is addition. If we add 0 plus 5, we get 5, a whole number. 4 plus 7, the answer is 11, which is also a whole number. In general, a plus b is a whole number for any two whole numbers a and b. If first and second numbers are whole numbers, then we will always get the answer as the whole number. So therefore, whole numbers are closed under addition. Now let's see the next operation, subtraction. 5 minus 7. We got the answer minus 2 because one number is positive, the other number is negative. So we have to do the subtraction. So that's why we got 2 and we have to give the sign of bigger number. So 7 is the bigger number, it has minus sign. So the answer is minus 2, which is not a whole number. So whole numbers are not closed under subtraction. Now let's see the next property, multiplication. 0 into 3 is equal to 0, which is a whole number. 3 into 7, the answer is 21, which is also a whole number. In general, if a and b are any two whole numbers, their product AB is a whole number. So what is our remark? Whole numbers are closed under multiplication. And the last operation is division. 5 divided by 8. We can write it this way also, which is not a whole number because when we divide 5 by 8, we never get the answer in whole number. So whole numbers are not closed under division. So let's revise. For whole numbers under closure property, addition and multiplication, only the whole numbers are closed. Okay. Check for closure property under all the four operations for natural numbers. Now let's see the integers. Let us now recall the operation under which integers are closed. Now, as I told you, integer means the positive and the negative numbers together. The first operation is addition. Numbers minus 6 plus 5. One number is negative, one number is positive. The answer is minus 1. An integer, which is an integer. Minus 7 plus bracket minus 5. Again the answer is an integer, which is equal to minus 12. Is 8 plus 5 an integer? Yes, the answer is 13. In general, a plus b is an integer for any two integers a and b. So let's see the remarks. Integers are closed under addition. Next one is subtraction. 7 minus 5 is equal to 2, which is an integer. If 5 minus 7, we get the answer minus 2, which is also an integer. Minus 6 minus 8 gives minus 14, which is also an integer. So, integers are closed under subtraction. Minus 6 minus bracket minus 8 gives the answer 2, which is also an positive integer. 8 minus 6, after solving this we also get the answer which is an integer. So in general, for subtraction, for any two integers a and b, a minus b is again an integer. Check if b minus a is also an integer. Yes, it is also an integer. Now let's see the multiplication operation. 5 into 8 gives the answer 40, which is an integer. Minus 5 into 8 gives the answer minus 40, which is also an integer, only a negative integer. Minus 5 into minus 8 we get the answer 40, which is also an integer. So in general, for any two integers a and b, a into b is also an integer. Therefore, integers are closed under multiplication. Next property or operation is division. 5 divided by 8. The answer is 5 divided by 8, which is not an integer. So integers are not closed under division. You have seen that whole numbers are closed under addition and multiplication, but not under subtraction and division. However, integers are closed under addition, subtraction and multiplication, but not under division. Now let's see the rational numbers. Recall that a number which can be written in the form p upon q, where p is the numerator and q is the denominator, where p and q are integers and q is not equal to 0, is called a rational number. For example, minus 2 upon 3, 6 upon 7 are all rational numbers. Since the numbers 0, minus 2, 4 can be written in the form of p upon q, they are also rational numbers. You know how to add two rational numbers. Let us add a few pairs. The first one is done. 3 upon 8 plus bracket minus 5 upon 7. After adding, see, their denominators are not same. So let's find out their LCM, which is 56. After making their denominators same, we get the answer minus 19 upon 56, which is a rational number. Now let's add minus 3 upon 8 plus minus 4 upon 5. Their LCM is 40 and minus 15 plus minus 32. The answer is minus 47 upon 40, which is again a rational number. Now you try this example and find out the answer whether it is a rational number or not. We find that sum of two rational numbers is again a rational number. Check it for a few more pairs of rational numbers. We say that rational numbers are closed under addition. That is, for any two rational numbers a and b, a plus b is also a rational number. Will the difference of two rational numbers be again a rational number? We have minus 5 upon 7 minus 2 upon 3, making their denominators same by taking out the LCM. We got the answer minus 29 upon 21, which is a rational number. The next is 5 upon 8 minus 4 upon 5. Let's solve this. The denominator are not same. So the LCM is 40. After making the numerator and denominator, we got the answer minus 7 upon 40, which is also a rational number. Now students, you try this equation and find out whether the answer is rational or not. Try this for some more pairs of rational numbers. We find that rational numbers are closed under subtraction. That is, for any two rational numbers a and b, a minus b is also a rational number. Now next point, let us now see the product of two rational numbers. The meaning of product is the multiplication. Minus 2 upon 3 into 4 upon 5, which gives the answer minus 8 upon 15, which is again a rational number. 3 upon 7 into 2 upon 5, both are positive. We get the answer 6 upon 35, which is also a rational number. Now try for the next one. Take some more pairs of rational numbers and check that their product is again a rational number. We say that rational numbers are closed under multiplication. That is, for any two rational numbers a and b, a into b is also a rational number. Let's see the point D. We note that minus 5 upon 3 divided by 2 upon 5. After solving this, we get the answer minus 25 upon 6, which is a rational number. Now let's solve the next question. Let's solve this. 2 upon 7 into 3 upon 5, the reciprocal of it. Now 2 into 3 is 6 and 7 into 5 is 35. The answer is again a rational number. Now you try for the next one and find out whether the answer is also a rational number or not. Can you say that rational numbers are closed under division? We find that for any rational numbers a divided by 0 is not defined. So rational numbers are not closed under division. However, if we exclude 0, then the collection of all other rational numbers is closed under division. Now, try to solve this chart on your own after listening the explanation. So student, this is our closure property for all the whole numbers, natural numbers, integers and rational numbers. I will explain the commutative property in my next video. Thank you.